All right, so if you're an analytics engineer, you've probably hit this point. You've mastered the basics, you're building data pipelines people actually trust, and then it all starts to grind to a halt. Everything's getting slower, your cloud bill's creeping up, and it's all just getting complicated. So what's next? Today, we're going to go beyond the fundamentals and talk about how to handle the challenges that come with success. This quote just nails it, doesn't it? Getting to a safe, predictable workflow, look, that was phase one. That was the hard part we all had to get through. But now you're in phase two. And phase two is all about designing a system so that your own success doesn't completely crush you under exploding costs and just the sheer mental weight of it all. It's about building for growth.
So, here's our game plan for this explainer. We're going to start by talking about scale as the new frontier. Then we'll dive right into the nitty-gritty, making your models smarter and faster, moving from simple tests to rock-solid data contracts, and figuring out how to tame that giant monolithic data project. We'll wrap up with automation and observability, all to help you build what we're calling the architect's mindset.
Okay, let's start with this shift because it's absolutely crucial. When you're starting out, everything is about building trust, right? Can people rely on your numbers? Is the data safe to use? But as soon as you nail that, a whole new class of problems just pops up. Your success creates more demand, and suddenly, the game isn't just about trust anymore. It's about efficiency in managing this beast of complexity you've created.
And that leads us directly to the first major headache, performance. I mean, it's inevitable. As you add more data, more users, more models, everything starts to slow down, and it gets more and more expensive to run. So what do you do when the basic tricks just aren't cutting it anymore?
Come on, you've been there, right? You open up the billing console and your heart just sinks a little bit. Your key dashboards are taking forever to load, and people are starting to complain. Look, this isn't a sign that you failed. It's a sign that you've succeeded. It's a scaling problem. It's the universe telling you it's time to level up your skills.
The old way of dealing with this is, well, it's pretty basic. You check if the source data is fresh. Maybe you just run your models less often. But the real, professional, scalable approach, it's a complete shift in how you build. You have to stop rebuilding your tables from scratch every single time and start mastering incremental models.
The idea behind an incremental model is it's beautifully simple. Instead of wastefully reprocessing years of historical data every single morning, you just tell the system, hey, only process the rows that are new or have changed since the last time we ran. This is an absolute game changer for your warehouse bill and for performance. But here's the thing. It's not as simple as just flipping a switch. You've got to master the skills to back it up. That means designing really robust logic to figure out what's new, learning how to partition and cluster your tables so the database can find data efficiently, and always writing your SQL with an eye on cost reduction. Okay, making our models fast and cheap, that's a huge win. But what's the next thing that breaks when you scale? It's your dependencies. Some other team makes a change upstream, they don't tell you, and poof, your pipeline breaks. And guess who's left cleaning up the mess? It's time to stop being reactive and start being proactive.
Think of it this way. The old way was to put a bunch of unique and not null tests on your tables. That's like putting a smoke detector in your house. It'll tell you when there's a fire. The new way, data contracts, is like installing a fire sprinkler system. You're trying to prevent the fire from even starting.
So what is a data contract? At its heart, it's a promise. It's an agreement where a data producer says, I guarantee that the shape, the columns, the data types of this data set will not change without warning. It's less of a technology and more of a social agreement, backed by technology that brings stability and predictability to the entire ecosystem.
And to make this happen, you need to learn how to enforce schemas the second data lands in your system. You need to think about versioning your data models just like a software engineer versions an API, so that big changes are intentional. And it means building governance, like tagging sensitive information right into the fabric of your work.
So, check. We've optimized our models. Check. We've secured our dependencies. But now we hit a totally different kind of scaling problem, a human one. Your single, central DBT project has become a victim of its own success, and trying to collaborate is just getting chaotic.
I mean, just stop and picture this. You've got 50 different people, all pushing code to the same project, with thousands of models that are all tangled together. It's impossible to understand what's going on, making a simple change is terrifying, and your CI jobs take forever to run. That, my friends, is the monolith problem.
The solution here is a massive architectural leap. You have to move away from one giant project where everybody works and towards a federated mesh of smaller projects, each owned by a specific domain team. Everyone owns their little piece of the puzzle, but they can connect to each other's pieces in a safe, controlled way.
This pattern is often called a data mesh, and tools like dbt Mesh give you the framework to actually do it. The idea is to decentralize. The finance team owns the finance data project. The marketing team owns the marketing data project. And they expose clean, stable public models to each other. It gives teams autonomy while still maintaining order.
Now, this requires you to really start thinking like an architect. You have to figure out how to split that giant project up along business domains. You have to master the tools for making those cross-project references safely. And, most importantly, you have to define those clear, contract-driven interfaces between the teams we were just talking about.
All right, we are getting to the absolute pinnacle of scaled analytics engineering now. You've got fast models, you have stable contracts, and you have a decentralized architecture. The final piece of the puzzle is building a truly mature operational practice around it, and that means automation and deep observability. And we are talking way beyond your basic CI/CD here. A mature pipeline starts with automated code quality checks, or linting. Then, you make your CI slim, meaning it's smart enough to only test the things that were actually affected by a change, which makes it way faster. From there, you get into advanced strategies like blue-green deployments for zero downtime. And the final step? Proactive anomaly detection.
Let's be clear, observability is so much more than just testing. A test can't tell you if your daily user signups suddenly dropped by 90%, but an anomaly alert can. It's about finding the unknown unknowns. It's also a cultural thing, having a real plan for when things inevitably go wrong and running blameless postmortem so you can learn and make the whole system stronger.
So, let's zoom out and tie all of this together. Mastering performance tuning, data contracts, federated architectures, and observability. This isn't just about learning a few new tricks. This is about a fundamental evolution of your role as an analytics engineer.
And this is the payoff. This is why you do all this hard work. By applying these architectural principles, you are the person who is directly driving down cost, cranking up the speed of insight for the entire company, and most importantly, you are taming complexity so the business can keep growing without everything falling apart. And that really brings us to the most important takeaway of all. Your job title might say analytics engineer, but when you're working at scale, you are an architect. You're not just a builder writing SQL queries anymore. You are designing the systems, the rules, and the contracts that let hundreds of people work with data effectively.
So I'll leave you with this one final question to think about. Your company's data is scaling. We know that. The volume and complexity are only going up. So you have to ask yourself, is your architecture ready for what's coming next?